What's up, YouTube? My name is Ben. You're watching Pragmatic Software Engineering. Now, this week we're not going to talk about data structures. I'm going to give you a little bit of a reprieve. Instead, we're going to be talking about something else. We're going to be talking about software testing. Specifically, we're going to be talking about unit tests today and go over a few things you want to know about testing software. So let's talk about some terms we're going to learn about. We're going to be learning about a unit test, which is a way we can test some sort of code in our system. And a test suite is a collection of unit tests. Within a unit test, you make assertions. And the things you test, the code you test, is called a feature. So when we're writing software, we have to find a way to validate that our code is correct. We write a lot of code all the time. We check it for syntax errors. We need to check it for logical correctness. And when we do this, we can actually find a way to document this behavior. So that allows us to know why a feature is written the way it is and what it truly does. And as a product matures more and more, we can lean on these tests to make sure we don't create a regression or something that causes features in a certain release to not work and make life a little bit harder for the user. And this is not a novel idea. In fact, all languages have testing frameworks. To name a few, Java has JUnit, Python has PyTest, Node.js has Jest. Again, non-exhaustive list, but those are some libraries that you can use for those languages. There are even more libraries per language. As an example, I use a unit testing framework called Spock for Java at work. And hopefully, if we play our cards right, we'll be doing some sort of YouTube mini-series on Spock. Now, tests are like keeping your house clean or keeping your room clean. And sometimes we neglect to do it. Tests are a labor of love. Because they're time-consuming, you have to spend the time to write out the test, make sure it works, and make sure it is a clean test. They require upkeep. So that means when people are adding to a system, they may break the unit test, but the code actually may be implemented correctly with a new feature. So they have to go back and update that unit test to now accept that new behavior. A lot of times when we write test code, we write really poor code just to test something and make it work. And this is called a brittle test. These tests, they break very easy. So one thing that you need to do when you're writing your test is realize that this is real code as well. It may not get run in production, but it needs to be thought through and it needs to be subject to best practices. And finally, tests are often skipped because they take time or because they create this inflexibility of the code. Now, you can run tests whenever you would like. You can run them at your workstation. You can use tools to run them. You can create scripts to run all these tests and things like that. They can run anywhere. But I typically see the most used in build jobs or when we're trying to build some code that's about to go to production. And the benefit of having these tests in these build jobs will be if any test fails, the deployment to production will fail and explain which test is failing this. This prevents us from putting bad code into production. Unit tests. These test actual code. They test the features in the code, the actual program we write. Now, unit tests are awesome, but again, they can be taken to a fault. And you want to be aware of over-testing. So over-testing looks like you write way too many tests to test every single thing, and you may create redundant tests. Another pitfall of unit tests is creating too many assertions in a singular unit test. So, as an example, you have something that tests that, the car wheels are turning, right? But in this test, you're also making the assertion that gas is coming into the car, exhaust is coming out to the tailpipe. That just becomes way too difficult to handle. When a unit test fails, you want to know exactly why using, the name of the test, or from just knowing the test suite, having such granular tests that fail allows you to understand and target where the bug is in the code. And the other thing you don't want to do when you have unit tests, you do not want to test other people's code. And I don't mean this like you don't want to test your coworker's code. What I'm saying is if you import a library from the internet or something like that, and the library, let's say, parses HTML, when you're making a test, you don't need to test that the library that came in, that its job works. Maybe you want to test that you can select, or your code may select the head and add a child. Well, then make your test, select the head, and check the children to see if that child has been added. Don't dump out the entirety of the HTML and do a string comparison. That's not needed. We know that the library works. So let's write some unit tests. So we're here in IntelliJ, and what we want to do is we want to create a function that swaps two elements in an array. So the way I like to do this, I like to make my IntelliJ work for its living. So I usually go up to the main class, the class that I'm testing, and I hit Alt-Enter, and I try to create a class. And yes, I'm comfortable with creating a test in the same source root. Now, I could use JUnit 5, and I could use JUnit 4. You see Spock again here. I really love using it, but I'm going to use JUnit 5 for today. So we've created our main test class, and I don't really want to talk about the benefits of test-driven development, but I'm just going to tell you I tend to like to write my tests first. So let's create a test by using this annotation. This is the @test. And I create a public void test swap array. And it doesn't have any parameters in it. And what we can do here is we can create an array. We'll just call it array. And we'll make sure that this array is of size 2. In fact, I think I can do 0, 1 to make an inline array. I can. Now what I want to do is I want to create a function called swap. So I'm going to go main.swap array. This function does not exist, and I'm going to give it two indices to swap. So I'm going to say 0 and 1. And then what I can do is go into assertions dot assert equals, and I can do array 0 is equal to 1, and I can also do this this way. Now, if I run this test, what will happen is we will create the array, we will call this function, and JUnit will use a special, way of treating this function where it will see if this evaluates to true, and it will see if this evaluates to true, and if it does, then the test is considered successful. Let's run it when we know it's going to fail. Okay, cool. So cannot find symbol. So now what I'd like to do is I'd like to use Alt-Enter again and create this swap method in main. And I'm just going to leave this, we'll do this index 1, and we'll do this index 2. Let's go back to our main test and let's run it again. It's going to fail this time. And you can see there is an assertion failed error, and it shows us what we expected and what we actually got. So I've added another function here that does basically the same thing, but with different values. So I want us to change this problem a little bit just to show you. Now there is really no good reason I'm doing this, but just to show you how to deal with dependencies in a test. So if we go to main.swap and we change it to not be a static function, but to actually be a non-static function, it needs an instantiation of main. What we have to do, or what we can do, is in order to compensate for this, we can create a static attribute, just call it main, and to set this up, what we don't use a constructor in a test, which is kind of odd thinking about that, but we don't often use a constructor in for tests. What we can do is before all, we have a public static void, and you can name your function whatever you'd like. I'm just going to call mine setup before all, and you can run some code in this. And for me, for this test to make sure it works, what I'm going to do is I'm going to instantiate this main. I changed this to be referencing the instantiation instead of the static function itself, and I run it, and it works. Again, let's change this a little bit more. We're going to basically have this Boolean call and call it isCalled, and we're going to set it to false. So when we try to swap, what we're going to do is we're going to see if isCalled is true, and if it is, we're going to just, I don't know, throw an exception, illegal state exception. We'll call it I've already been called. What we will do here is we will set isCalled to true. So basically, once we call this function and we call it again, we're going to throw an exception. So what we'll do here is we'll also add a clear function. This will be void. And when you clear this main class, we're going to say isCalled equals false. So now let's run this test once more. And it's going to fail, or at least one of them is going to fail because I've already been called. So if you need to do some sort of cleanup before, if you need to do some sort of setting before each run of the test, you can actually just use the before each annotation here. And we'll just call this public void setup each. And I'm just going to say main.clear. So whenever we run one of these functions, or right before we run any of these test functions, these unit tests, we will call this clear function, and we should be good to go. There are counterparts to before all and before each, and they are after all and after each. So if instead you need to do setup before, you need to do cleanup afterwards, you can use after all and after each. Now, when you're testing things like database connections and things like that, where you're testing how a piece of code reacts to a dependency, you will likely see both befores and after annotations in a unit test. So you can actually do a lot of different things with assertions. You can do assert equals, there's assert true, there's assert array equals, and you can actually do something where you assert that an exception is thrown. Now, I'm not going to teach you how to check if an exception is thrown, only because you have to use a lambda, and I want to make sure that you understand what a lambda is and how to use it before we go on to using them, obviously. So after we talk about lambdas in Java, we can talk about assert exceptions or verification that exceptions are thrown.
So I know you didn't ask for it, but here's my opinion on testing. Because whenever we're talking about testing, when you're talking to an engineer, they always find a soapbox. I'm not sure where mine is right now, and they tell you about their opinion. Software testing is a necessity when you're creating features. I am really bullish on software testing. So when someone asks me to review their code and there are no tests, I will ask the person to create those tests. The reason is, when you create those tests, you create this idea of a contract of what your code has to uphold when it goes to production. And having that is not only good for yourself, but in 6 months, when you change a piece of code and you break a test, and your test doesn't go to production because, your code doesn't go to production because the test doesn't work, because you thought that you made it a safe change, you're going to be thanking yourself or thanking whoever wrote that test prior to you, that they wrote that test because you would have just pushed a bug to production. So I hope you enjoyed this video. Testing is an awesome tool we have in software to make sure that we're right. I hope you enjoyed this video. Please like and subscribe. Thanks.